Hello everyone. In this video, I want to share with you an application that will hopefully help improve your future educational experiences for mapping terrain. So I'm in our VLE under Session 3 for Hill Slope Analysis and Local Terrain Report. In here, you'll see a link that will take you to a new slope analysis application. When you click this link, you'll be prompted to log on, and I have assigned you each credentials, which will be your student number, .sce _ tssgrad, and a password. So you'll log on right here. Let me know if you have questions. But when I log on with my account, I can show you what this application is all about. This application will open you up to a viewer where you can interpret slopes all throughout the country. It's pretty cool. The first thing you'll want to do is to find your slope that you were analyzing this week. So with the search bar right here and these tools, zoom in, zoom out, you can navigate to any location in the country. So I can see I'm going to head down to Somsey, and I want to zoom in on that slope that I was showing you all during our video. Yeah, right up here by Dum Dum. Now this tool is really great because it has a few special layers that you can add. If you click this button over here for the legend, you'll see you have a few different terrain analysis features. You can turn on a map of the different slopes, and this will automatically display the relative slope of your area, calculated from this digital elevation model. You can click onto any point, and it will compute what the slope is at that position and give you your actual slope angle. How cool. You can also look at your aspect of the area. This will produce tons of colors, but these colors relate to the direction that your slope is facing. Now, one of the best tools that can help, we often talk about relief in terms of topographic lines, right? However, this tool down here can really help to investigate your different topography. If you click on the pencil, you can examine your slope and draw a line, first by clicking and then double clicking to end. And this will produce a profile that shows the different elevations in between. So what's really great is that with this profile, you can see the shapes of your slope. I can see this slope is convex up at the top, and then rotating more towards concave down below. And it'll actually compute your minimum, your maximum values, and then show your change in elevation. One final thing to look at is this world relief button. If you click this button, it will produce a new layer that you can zoom out and calculate your local relief. So remember, when we're talking about those threshold slopes, the local relief is so important. And if you click anywhere on that map, you can see what your local relief is. So above 1,000 meters, which means threshold slopes are dominating. So with this tool, I want you to try to analyze your local slope and play around with what you're seeing. A great thing to do is to put on some different features, and then you can take a screenshot of your screen to start to make some cool pictures. And then you can add and adjust and compare what you were seeing in the field with some analysis online. and make some really cool photos to show your field observations, your local steepness, and then if you have different complexities with your geometry. So for this week's assignment, what I'm going to ask you to do is make a short report following these instructions. Give a short description of what you noticed in the field. Play around with this analysis tool and share some data. What did you find for your average slope? Tell us about the profile that you saw. And then give a brief description of your hill slope. What shape is it? And how would you classify this? Is it a threshold slope? Or is it one of those transport-dependent soil limiting slopes? Don't forget to include a picture from your field visit and a snapshot of your online analysis. I look forward to seeing what you can come up with. Good luck.